Now for beryllium dichloride, BeCl2, beryllium is going to be your central atom here. And the total number of valence electrons. Now remember, beryllium here is a special case. It's actually, it is a metalloid. It is very, there is a lot of ionic character to this bond. And chlorine has 7 valence electrons. And so what's going to happen here is the bond is actually going to be very ionic in nature. So this is almost going to be an ionic bond. And what's going to happen, because beryllium is a special case and doesn't need to gain 8 electrons in order to form a compound, we don't actually go through this whole process. So beryllium chloride is a special case that you're going to have to remember. And so the way this bonds is beryllium only needs 2 covalent bonds in order to be stable. And so it shares those electrons, and it pretty much gives up its electron to the chlorine. And in fact, the electrons spend more of their time around the chlorine because chlorine is so electronegative that this is very negative. It's partially negative, and then the central atom is partially positive, but in this case, it's almost positive enough to be considered in the realm of ionic. So this is the structure of beryllium dichloride, and once again, this is linear, and it's just like the case of carbon dioxide, which was linear as well, because there are no unbonded electrons around the central atom. So these 2 chlorine atoms are going to get as far apart from one another as possible. So this is going to be a linear structure.